What if everything you thought you knew about America's first inhabitants was wrong? Not a little wrong, not off by a few centuries, the kind of thing you fix with a footnote in a revised textbook. I mean, fundamentally, structurally, turn the whole thing upside down wrong. What if the story of how and when humans first set foot on this continent, a story that generations of archaeologists built their entire careers on, that shaped how we teach history in every school in the country, was missing the first chapter or the first several chapters? Here's a number, 13,000. That's roughly how many years ago, according to the dominant theory in American archaeology for most of the 20th century, the first people arrived in the Americas. They crossed a land bridge from Siberia to Alaska, moved south through an ice-free corridor in the retreating glaciers, and within a remarkably short time had spread across 2 continents. They were called the Clovis people, named after a site in New Mexico, where their distinctive stone tools were first identified in the 1930s. And for decades, the scientific consensus was clear, confident, and, as we are now discovering, profoundly incomplete. Because the evidence keeps piling up. Site after site, artifact after artifact, footprint after fossilized footprint. Evidence that people were here not 13,000 years ago. Not 15,000, not even 20,000. Evidence that pushes the clock back further than most mainstream archaeologists were willing to accept even a decade ago. Evidence that suggests the story of America's first people is older, stranger, and more complex than anyone imagined. Tonight we're going underground, into the dirt and stone and sediment where the real history is written. And we're going to find out what the evidence actually says and why it took so long for the scientific establishment to listen. Let's start with the theory that dominated American archaeology for most of the 20th century, because to understand why the new discoveries are so explosive, you need to understand just how thoroughly the old model had taken hold. The Clovis first hypothesis was born in the late 1920s and early 1930s, when archaeologists working near Clovis, New Mexico, discovered something remarkable: distinctive, beautifully crafted stone spear points in direct association with the bones of extinct megafauna. Mammoths, mastodons, ancient bison. The points had a characteristic flute, a channel flaked from the base to allow hafting to a shaft that was unlike anything found in the Old World. They were uniquely American, and they were clearly old. As dating technology improved through the middle of the 20th century, the Clovis sites clustered consistently around 13,000 to 13,500 years ago. And when archaeologists looked at the geological record of that period, it seemed to fit perfectly with a compelling migration narrative. About 13,000 years ago, retreating glaciers had opened an ice-free corridor down the center of North America, connecting Alaska to the unglaciated south. There was a land bridge, Beringia, still connecting Siberia to Alaska. The route was open, the timing worked, the story made sense. And so the Clovis first model hardened into consensus. Not just a hypothesis, a paradigm, the kind of deeply embedded assumption that shapes how researchers frame their questions, design their studies, and interpret ambiguous evidence. If you found something that looked older than Clovis, you questioned your dating. You questioned your context. You looked for contamination, for stratigraphic disturbance. For some reason, the finding couldn't mean what it appeared to mean. Because the finding couldn't mean what it appeared to mean, because Clovis was first. This is not a criticism unique to archaeology or to this particular debate. It's how paradigms work in science generally. The philosopher Thomas Kuhn described it in the 1960s. Established scientific frameworks don't just organize knowledge, they shape perception. They determine what counts as evidence, what counts as noise, and what gets dismissed as the result of methodological error. Anomalies accumulate quietly at the edges for years, sometimes decades, before a tipping point is reached and the framework finally shifts. American archaeology is at that tipping point right now. Has been for a while, actually. The question is just how many people are paying attention. The problem with Clovis first. Before we get to the specific sites and discoveries, it's worth understanding exactly why the Clovis first model was always a little fragile, even before the anomalous evidence started piling up. The fundamental problem was chronological and geographical. If the Clovis people entered North America through the ice-free corridor around 13,000 to 13,500 years ago, and if they then populated both North and South America, they had to move fast, extraordinarily fast. By 13,000 years ago, we already have Clovis sites spread across much of North America. By 12,500 years ago, we have evidence of human presence at Monte Verde in southern Chile. And Chile is about as far from the Beringian land bridge as you can get while still being on the same continent. To get from Alaska to southern Chile in 500 to 1,000 years, moving through unfamiliar terrain, crossing unknown river systems, navigating the Darien Gap, the dense jungle connecting North and South America that stopped the Pan American Highway dead in its tracks in the 1970s, you'd have to maintain a rate of southward expansion that some researchers found implausibly fast. Not impossible, not definitively ruled out, but fast enough to raise eyebrows. There was also the problem of what humans were apparently doing in Beringia, in Siberia, in the millennia before the ice-free corridor opened. Archaeological evidence from northeastern Asia shows human populations capable of surviving in harsh, glacially influenced environments well before 13,000 years ago. If people were that far east and that capable, why would they have waited at the edge of the continent for the corridor to open? Why not take to the coast? Why not follow the Pacific shoreline? A route that, even during the glacial maximum, would have offered marine food resources, relatively ice-free passage, on a continuous southward path? The coastal migration hypothesis had actually been proposed decades earlier, but it was largely set aside because the coastal sites from that period would now be underwater. Sea levels were dramatically lower during the glacial maximum. The ocean's surface was down by 300 feet or more in some areas, and the coastlines that humans might have traveled are now sitting on the continental shelf beneath fathoms of water. Absence of evidence in this case was very much not evidence of absence. Those sites might exist. They're just inaccessible with conventional archaeology. So even before a single anomalous pre-Clovis artifact was verified, there were structural reasons to be skeptical of the model. The timeline was tight. The route was uncertain. The absence of coastal evidence was explained by circumstances rather than by the actual absence of people. The Clovis first model was dominant. But it was dominant through momentum as much as through ironclad evidence. The resistance. When pre-Clovis claims began to emerge with increasing frequency from the 1970s onward, they didn't receive a warm welcome. And understanding the reception they got is essential to understanding why this story has taken so long to break through to public consciousness. The problem wasn't that archaeologists were uniquely closed-minded or perversely devoted to a failing paradigm. The problem was that some earlier pre-Clovis claims had turned out to be based on flawed evidence. Poorly documented contexts, contaminated dating samples, artifacts that turned out to be natural geological formations rather than human manufacture. The field had been burned before, and so a reflexive skepticism toward any pre-Clovis claim was in many ways epistemically reasonable. But over time, that reasonable skepticism calcified into something less defensible. Researchers who published legitimate pre-Clovis findings reported being dismissed at conferences, having their papers rejected by journals despite solid methodology, finding their careers subject to informal pressure. Tom Dillehay, the archaeologist who spent decades excavating and defending Monte Verde in Chile, the site that ultimately did more than any other to break open the Clovis first model, described years of professional difficulty, of being subjected to a level of scrutiny that contemporary Clovis-era work simply wasn't facing. This is the sociology of science doing what the sociology of science sometimes does. Paradigms protect themselves, and the Clovis first model had been established long enough and was defended by prestigious enough figures that challenging it required extraordinary evidence presented with impeccable methodology. When the bar for pre-Clovis claims was not the same as the bar for Clovis consistent claims, and that asymmetry slowed the revolution considerably. What finally changed things was not a single spectacular discovery, though we'll get to the spectacular discoveries, but an accumulation. Site after site, independently verified by teams with no particular ideological commitment to overturning the model, using multiple lines of dating evidence, producing consistent results. At some point, the weight of evidence simply became too great to explain away, and the field began, slowly and sometimes grudgingly, to shift. Monte Verde, the site that started the revolution. If there's a single site that cracked the Clovis first paradigm open, it's Monte Verde. And the story of Monte Verde is as much about institutional resistance as it is about archaeology. Monte Verde is located in southern Chile in the Lake District, about 500 miles south of Santiago. In the mid-1970s, a veterinary student named Michel Iraz discovered unusual bones eroding from a creek bank. He brought them to the attention of Tom Dillehay, then a young archaeologist at a local university, and what followed was decades of one of the most significant and most contentious excavations in the history of American archaeology. What Dillehay's team found was extraordinary. A campsite, not a kill site, not a tool manufacturing location, but an actual campsite. An intimate, a detailed snapshot of daily life. There were the remains of wooden tent-like structures, anchored with wooden stakes and apparently covered with animal hides. There were hearths, there were remnants of food, mastodons, small vertebrates, over 40 species of plants including potatoes and seaweed, gathered from the Pacific coast about 60 miles away. There were clay-lined pits that appeared to have been used for cooking or food storage. There were stone tools, but also tools made of wood and bone that rarely survive in the archaeological record. The picture that emerged was of a community, not lone hunters chasing megafauna, but a group of people with a sophisticated, diversified subsistence strategy, exploiting a wide range of environments, carrying medicinal plants, building structures, fully human in every behavioral sense. And the dating came back consistently around 14,800 years ago. And some evidence from a deeper layer suggested a possible human presence even earlier, potentially around 33,000 years ago. Though Dillehay himself has been cautious about the lower layer, given how extraordinary that date would be. The 14,800-year date was already devastating enough to Clovis first. This was 1,800 years before the ice-free corridor opened. This was at the opposite end of two continents from the supposed point of entry. Well, how do you get people to southern Chile 14,800 years ago if the first Americans only arrived 13,000 years ago via a corridor that didn't yet exist? The answer the evidence suggested was uncomfortable for the paradigm. They took the coast. They came earlier, and they moved faster or via a different route than the Clovis first model allowed for. The response from mainstream American archaeology was, at first, withering skepticism. The site was criticized on multiple grounds. The dating was questioned, the identification of some wood fragments as human work was disputed, the overall stratigraphy was challenged. Dillahey spent years answering these objections, revisiting the site, gathering more data, submitting to scrutiny that went far beyond what any comparable Clovis-era site had faced. In 1997, a team of prominent archaeologists, some of them previously skeptical, visited Monteverde and conducted an independent review. Their conclusion was carefully worded but clear. The site was genuine, the dating was solid, the evidence of pre-Clovis human occupation was valid. It wasn't a complete capitulation from the Clovis first camp, but it was a significant crack. The conversation began to shift. A Buttermilk Creek. Texas rewrites the timeline. While Monteverde was cracking the consensus from the south, a site in central Texas was doing it from within North America itself. The Buttermilk Creek complex at the Deborah L. Friedkin site in central Texas produced results that were harder for North American archaeologists to dismiss because it was right in their backyard. The site had been known to researchers for some time, but systematic excavation beginning in the late 1990s and continuing through the 2000s eventually reached a layer beneath the Clovis horizon that contained thousands of artifacts, stone tools in various stages of manufacture, waste flakes, the full range of material you'd expect at a working tool production site, not just a few anomalous pieces that could be explained away, but a substantial, unambiguous assemblage. The dating, well, using a technique called optically stimulated luminescence, which measures when sediment grains were last exposed to light and is independent of organic material, placed the assemblage at 15,500 years ago. That's 2,500 years before Clovis. And the tools themselves were interesting. While they weren't Clovis points, they showed technical sophistication and, in the view of the excavators, that a technological relationship to Clovis that suggested these pre-Clovis people might actually be the ancestors of the Clovis culture, not some separate, unrelated population. This was a significant reframing. Rather than having to explain where the pre-Clovis people went and why they seemingly disappeared before Clovis emerged, the Buttermilk Creek evidence suggested a continuous technological tradition developing over millennia. The Clovis people didn't appear out of nowhere with their fluted points. They developed from earlier populations who had been working the same stone in the same region for thousands of years before. The pushback came, as it always did. The dating method was scrutinized. The identification of the tools as definitively human-made rather than naturally formed was questioned. But the team's methodology was solid, the assemblage was large and consistent, and the findings have held up through subsequent independent review. Buttermilk Creek mattered because it put pre-Clovis evidence in the continental United States with clear stratigraphic context using modern dating methods, producing results that multiple researchers have examined and validated. The Gault Site, a discovery hiding in plain sight. And then there's the Gault Site, also in central Texas, also in the Buttermilk Creek watershed. Gault is one of the most significant and most extraordinary pre-Clovis discoveries in North America. And what makes it particularly remarkable is that the site had been known to archaeologists for decades before the pre-Clovis implications were fully understood. Gault is enormous. It's been a productive archaeological site since the early 20th century, and decades of excavation have produced enormous quantities of Clovis material. It was considered one of the major Clovis sites in North America. But below the Clovis layer, excavators working with increasingly sophisticated methods found something older. What they found were artifacts, scrapers, blades, blade cores, bifacial tools that were clearly human-made, clearly in stratigraphic context below the Clovis material, and dated to between 16,000 and 20,000 years ago. Some of the material may be even older. And what makes the Gault pre-Clovis assemblage particularly interesting is what it looks like. The tools don't look like Clovis, and they don't look like any previously identified North American tradition. They represent apparently a distinct technological approach that predates and differs from Clovis. This matters enormously. If pre-Clovis people at Gault were using a completely different technology from Clovis, it suggests that the peopling of the Americas wasn't a single event. It wasn't one population crossing Berinia and spreading south. It was potentially multiple waves, multiple groups, possibly multiple routes, developing distinct cultural and technological traditions independently. The implications ripple outward in every direction. They affect our understanding of migration routes. They affect our understanding of the relationship between early American populations and modern indigenous peoples. And they affect our understanding of how fast and how far early humans were capable of moving across unknown landscapes. The Gault Site, sitting in central Texas for a century of archaeological attention, had been hiding part of its secret all along. White sands, footprints in time. We've talked about stone tools and campsites and technology. Now I want to talk about something more viscerally immediate, something that connects across 20,000 years with a directness that no artifact can quite match. Footprints. In 2021, a team of researchers published findings from White Sands National Park in New Mexico that stopped the archaeological world cold. In the dried bed of an ancient lake, Lake Otero, which dried up thousands of years ago, they found human footprints. Not just a few. Dozens of trackways preserved in ancient lake sediments, documenting the comings and goings of real people. Footprints are remarkable things. A stone tool is an object, something made and then left behind. A footprint is a moment. It's a person in motion, mid-step, doing something, walking somewhere, carrying something, in a hurry or moving slowly. The White Sands footprints include the tracks of children running, of adults walking alongside megafauna, giant ground sloths and mammoths, and of at least one individual who appears to have been carrying something heavy. Given the depth and angle of the impressions, they're human. They're unmistakably, undeniably human. The right shape, the right size distribution for adults and children, the right gait patterns. No geological process makes footprints that look like these. And the dating, the seeds of an aquatic plant called Ruppia serosa, found within the sediment layers containing the footprints, were radiocarbon dated to between 21,000 and 23,000 years ago. 21 to 23,000 years ago. A people were walking in what is now New Mexico more than 20,000 years ago. To put that in context, this was during the last glacial maximum, the peak of the last ice age, when the ice sheets were at their greatest extent. The Beringian land bridge existed, but the ice-free corridor through North America did not. If people were in New Mexico 21,000 years ago, they did not get there through an ice-free corridor. They got there some other way. Along the coast, by boat, or through routes we haven't yet identified, or by a combination of all of these. The White Sands findings generated debate immediately, as they should. The radiocarbon dating of aquatic plant material is subject to what's known as the reservoir effect, a phenomenon that can make aquatic organisms appear older than they actually are because they're absorbing older carbon from the water. Critics raised this possibility, and the research team anticipated it and addressed it with additional dating methods, including optical luminescence dating of the surrounding sediment. The results were consistent with the radiocarbon dates. The footprints are real. The dates appear to hold. And 21,000 years ago is not a number that fits comfortably anywhere in the Clovis first model. Cerruti mastodon, the most controversial claim. Not all pre-Clovis claims have the same level of evidentiary support. And it would be intellectually dishonest to present this field as a simple parade of confirmed discoveries without acknowledging that the most dramatic claims are also the most contested. The Cerruti Mastodon site in San Diego is the most extreme example. In 1992, during freeway construction, workers uncovered mastodon bones along with a collection of cobbles that showed, according to the researchers who subsequently analyzed them, and were the kind of spiral fracture patterns and percussion marks associated with human butchery. The hypothesis was that early humans had used stones to break open mastodon bones, probably to extract marrow, leaving behind the characteristic patterns of breakage. So far, perhaps remarkable but not shocking. The shocking part is the date. Uranium series dating of the mastodon bones produced an age of 130,000 years. Not 13,000, not 23,000, 130,000 years. If the Cerruti mastodon interpretation is correct, it would not just overturn Clovis first. It would require a complete reimagining of human prehistory on a global scale. Because 130,000 years ago, anatomically modern humans had barely left Africa. The only hominins who could plausibly have been in California 130,000 years ago would be an archaic human species, perhaps Denisovans, whose range in Asia remains poorly understood, it or some other population whose presence in the Americas is otherwise unknown. The scientific response has been, predictably, extremely skeptical. The identification of the fracture patterns as definitively caused by human activity rather than natural processes, trampling, geological pressure, carnivore activity, has been strongly disputed. The dating, while technically sound, only tells you how old the bones are, not whether they were modified by humans at the time of death or much later. With the absence of any other evidence of human presence at that extraordinary time depth is a massive problem for the hypothesis. The Cerruti mastodon findings should be taken seriously as a scientific question, meaning they should be investigated rigorously and evaluated without either reflexive acceptance or reflexive dismissal. But the current state of evidence does not come close to supporting such a revolutionary conclusion. It sits at the extreme edge of what the evidence can support, and it serves as a reminder that not all pre-Clovis claims are created equal. The field requires discernment, not just openness. Roots into the Americas, rethinking the journey. The accumulation of pre-Clovis evidence doesn't just push back the date of arrival. It forces a fundamental rethinking of how people got here. And the routes question turns out to be at least as interesting as the timing question. In the traditional Beringian land bridge/ice-free corridor model had the virtue of simplicity. People walked from Siberia to Alaska across a broad, dry grassland. Beringia was not a narrow bridge, but a landmass the size of Australia, and then walked south when the glaciers retreated enough to open a passage. It required no specialized skills beyond the capacity to survive in a cold, open environment. Walking is something humans do. But here's the thing. We now have genetic, linguistic, modern archaeological evidence that suggests the story is far more complicated than a single migration event through a single corridor. Genetic studies of indigenous American populations have revealed patterns of diversity that point toward multiple migration events from Asia, potentially occurring at different times and involving populations with different genetic profiles. The deepest branches of Native American genetic ancestry appear to diverge from Asian populations around 25,000 years ago, consistent with a population that had already separated from the main Asian gene pool before the Clovis period, possibly isolated in Beringia itself for thousands of years before moving south. But layered on top of that deep ancestry are signals of additional genetic input, a connection to populations related to the ancient North Eurasians, a mysterious signal in Amazonian populations that appears to be related to Australian and Melanesian peoples, a finding that generated enormous excitement and considerable confusion when it was first reported. What that signal means, whether it represents an actual migration from the South Pacific, a connection through shared ancestry with ancient Siberian populations, or some other complex demographic history, remains a matter of active debate. But it speaks to a history of human movement into and across the Americas that is dramatically more complex than anyone imagined in the Clovis First era. The coastal route has become increasingly compelling as the terrestrial evidence for pre-Clovis occupation has mounted. The Pacific coastline, even at the height of the last glacial maximum, offered something the interior of the continent emphatically did not: a continuous food resource. Marine environments are productive year-round. Shellfish, fish, marine mammals, seabirds, intertidal invertebrates. A coastal subsistence strategy could support relatively rapid movement along a shore, even in cold conditions. The kelp highway hypothesis proposes that the productive kelp forest ecosystems of the North Pacific, which extend in a near-continuous band from Japan to Baja California, provided a kind of ecological superhighway for maritime-adapted people. We groups already experienced with boats and coastal foraging could have moved down this coastal corridor relatively quickly, arriving at the southern end of the continent thousands of years before any ice-free terrestrial route opened. The problem, as noted earlier, is that the evidence for this route is now underwater. But the circumstantial case is strong, and some underwater archaeological survey work is beginning along what are now the submerged continental shelves of North America. Now, this is slow, expensive, and technically challenging work. But if those coastal sites exist, and the evidence increasingly suggests they should, finding them would be among the greatest archaeological discoveries in history. Ancient DNA and the genetic revolution. The revolution in pre-Clovis archaeology hasn't happened in isolation. It's been accompanied and in some ways driven by a parallel revolution in ancient DNA analysis that has transformed our understanding of prehistoric human movement worldwide. 20 years ago, Extracting usable genetic material from ancient human remains was extraordinarily difficult. Contamination was a constant problem. The fragments of DNA that survived in old bones were degraded and sparse. The analytical techniques were primitive by current standards. Results were often ambiguous or simply wrong. The development of next-generation sequencing technology, combined with new methods for enriching ancient DNA fragments from bone and tooth samples, has changed everything. Researchers can now sequence full genomes from human remains tens of thousands of years old, allowing comparisons of extraordinary precision. They can identify specific mutations, trace population movements, calculate divergence times, and reconstruct the demographic history of ancient populations in ways that were simply impossible a generation ago. For the Americas, ancient DNA has produced several landmark findings. The genome of a young child recovered from a burial at the Anzac site in Montana, a Clovis burial, the only one ever found, revealed that this individual was ancestral to most modern Native American populations in both North and South America. This confirmed that the Clovis people were not replaced by some later migration. They were, in a real genetic sense, the great-great-grandparents of indigenous peoples across the hemisphere. But it also revealed that the Clovis people themselves were descended from a population that had diverged from Asian populations roughly 25,000 years ago, long before the Clovis culture itself appeared. That divergence event points to a population spending thousands of years somewhere, possibly in Beringia, possibly in eastern Siberia, possibly elsewhere, before the eventual southward movement. Then there's the mystery of the population Y signal in some Amazonian groups, a genetic component that appears related to the Onge people of the Andaman Islands and to Australian Aboriginal populations. Groups associated with the deep southern migration out of Africa that populated southern Asia and eventually Australia. How this genetic signal arrived in the Amazon remains one of the most fascinating unsolved puzzles in the genetics of ancient human migration. One hypothesis is that it reflects a very ancient dispersal through East Asia that reached the Americas earlier than the main Beringian migration. Another is that it reflects a complex ancestry in Siberian populations that we haven't fully untangled yet. Ancient DNA doesn't resolve the pre-Clovis debate by itself, but it adds critical dimensions to it. It gives us a biological layer that cross-checks and enriches the archaeological layer. And right now, both layers are pointing in the same direction, toward a more complex, earlier, and more geographically diverse story of human arrival in the Americas than anyone was prepared for. The climax. What does it all add up to? We've traveled through Chile, Texas, New Mexico, California. We've followed stone tools and footprints in DNA. When we've watched a scientific paradigm crack and begin to shift. So let's stop and ask the honest question. What does the evidence, taken as a whole, actually tell us? Here's where the mainstream of archaeological opinion has moved. As best I can summarize it, humans were present in the Americas significantly earlier than 13,000 years ago. The White Sands footprints, if their dating holds, and the evidence so far suggests it does, put people in North America at least 21,000 years ago. Monte Verde puts people in southern Chile by at least 14,800 years ago, with possible indications of earlier presence. The Texas sites at Buttermilk Creek and Galt push the North American occupation date back to at least 15,000 to 16,000 years ago, and possibly older. These findings don't fit within the traditional Clovis first framework. They simply don't. You cannot get people to southern Chile 14,800 years ago or to New Mexico 21,000 years ago, through an ice-free corridor that didn't exist yet. The corridor model, which was always the structural backbone of Clovis first, has been effectively falsified by the accumulation of evidence. What replaces it? The current leading model involves some combination of the following: an early coastal migration along the Pacific, possibly 20,000 or more years ago, carried by maritime-adapted people with boats or rafts and the skills to exploit coastal marine resources. A period of exploration and expansion into the interior of the continents as conditions change, followed by the Clovis fluorescence around 13,000 years ago, not as the first Americans, but as the descendants of earlier populations who had been on the continent for thousands of years, developing their technology as they went. The Clovis people were not the beginning, they were a milestone, and this changes everything about how we think about this period. And it means that the Americas were being explored and occupied during the height of the last ice age by people tough enough and resourceful enough to survive in conditions that no modern human has ever had to face. It means that the extinction of North American megafauna, the mammoths, mastodons, giant sloths, short-faced bears, American lions and horses and camels that all disappeared around 12,000 years ago, occurred in the context of a human presence that was thousands of years older than previously thought. The relationship between those extinctions and human hunting is now a more complex question than a straightforward story of Clovis hunters arriving and devastating naive megafauna in a brief burst of predation. It means that the indigenous peoples of the Americas are the descendants of a population with a deeper, longer, more complex history on this continent than any previous scientific framework acknowledged. Their ancestors were here not for 13,000 years, but potentially for 20,000, 25,000 years or more. The connection to this land is older and deeper than anyone knew. The shocker. The finding that changed everything I've been building toward this. And now I want to give you the finding that, for me, and for many researchers in this field, represents the moment when the pre-Clovis case stopped being a minority view and became something impossible to dismiss. It's the White Sands footprints, and I want to go back to them one more time, because I don't think the full weight of what they represent has been absorbed yet. Think about what a footprint is. It is not an artifact. It is not something made and deposited and potentially moved by geological processes. It is a direct, on a physical impression of a living person taking a step. The size gradation across the trackways, adult feet, adolescent feet, children's feet, documents a community in motion. The gait patterns are human. The depth and shape of the impressions are human. There is no plausible geological or biological process that creates a field of human-shaped footprints. And those footprints are 21,000 years old, potentially 23,000 years old. This is not a stone tool whose human manufacture could be disputed. When this is not an organic material whose radiocarbon date could be attributed to contamination or reservoir effects, though the researchers address those concerns, this is a foot, a human foot, walking across a lake bed in New Mexico 21,000 years ago. At 21,000 years ago, the Laurentide ice sheet, the enormous glacier that covered most of Canada, was near its maximum extent. The corridor that Clovis first required did not exist, but people were in New Mexico. People with families, when with children, people who walked around a lake and left their marks in the mud and kept walking and are gone now, 21,000 years gone, but not entirely gone, because their footprints are there. preserved in ancient sediment, waiting under the sand of what is now a national park, until a team of researchers in the 21st century started to understand what they were looking at. That is the shocker, not a theory, not a model, not a contested interpretation of ambiguous stone flakes, footprints. Human footprints, older than anything the Clovis first model can accommodate, preserved in the ground of the American Southwest, waiting to be found. The Clovis first model is not just challenged at this point. It is not just strained or revised or updated. It is broken. It cannot account for what we are finding. The first chapter of American history is not what we thought it was, and the real story, still being uncovered, still being debated, still being pieced together from sites scattered across 2 continents, is so much older and so much stranger and so much more remarkable than the version that was taught in textbooks for most of the 20th century. What the indigenous perspective adds. There's a dimension of the story that purely archaeological accounts often miss, and it deserves its own space. Many Native American traditions have always maintained that their peoples have been in this land since time immemorial. Not for a few thousand years as migrants from Asia, but since the beginning. The Clovis first model, arriving in the early 20th century with the authority of Western science, was often used to tell indigenous people that this wasn't true, that they too were migrants, just earlier ones, and that there was nothing uniquely ancestral about their relationship to this land. And this was experienced in many indigenous communities as another form of dispossession. Not physical this time, but historical. The erasure of an ancient presence. The reduction of thousands of years of relationship with a landscape to a brief chapter in a migration story. The new archaeological findings don't perfectly validate traditional indigenous accounts. Oral traditions are not literal geological records. And the timescales involved mean that specific stories about specific events 20,000 years ago would have undergone countless generations of change. But they do confirm something important: the deep time dimension of indigenous presence in the Americas. 21,000 years, possibly more. These are not recent arrivals. These are the deep roots of a human relationship with a continent that stretches back into the Ice Age. Some indigenous scholars and communities have been watching the pre-Clovis debate with interest, noting that the scientific establishment is, in a sense, finally catching up to what indigenous knowledge holders maintained all along: that the relationship between these peoples and this land is ancient, deep, and cannot be reduced to a simple migration story. This doesn't mean science and indigenous knowledge say the same things, or that they should be conflated, and they operate differently and serve different purposes. But the convergence here is worth noting. The archaeology is making the indigenous presence in the Americas older, deeper, and more complex. That is a correction in the right direction. Where the research goes next. The pre-Clovis revolution is not finished. It's arguably just beginning, and the next decade of research promises to be extraordinary. When underwater archaeology along the submerged continental shelves of North America is the most obvious frontier. If early coastal migrants moved down the Pacific shore, their camps and kill sites are now underwater. The technology to find and excavate them exists. Remotely operated vehicles, side-scan sonar, underwater excavation methods. But the work is expensive and logistically difficult. Several research groups are actively pursuing this, and the potential for discovery is enormous. Where the ancient DNA field is moving at a pace that would have seemed impossible 10 years ago. New techniques allow researchers to extract genetic information from increasingly degraded samples, to analyze environmental DNA, genetic material preserved in sediment rather than in bones, and to reconstruct population histories with increasingly fine resolution. Every new ancient genome from the Americas adds another data point to a picture that is becoming steadily clearer. A LiDAR technology, laser scanning from aircraft that can penetrate forest canopy and reveal ground-level features, is transforming the discovery of archaeological sites, particularly in the dense forests of Central and South America. It's already revolutionized Mayan archaeology, revealing enormous urban complexes invisible from the ground. Applied to pre-Clovis questions, it could identify sites and features that are simply impossible to find through conventional ground survey. And then there are simply more excavations happening, more researchers, better funded, with better tools, working at more sites across a broader geographic range than any previous generation of archaeologists. The accumulation of evidence that cracked the Clovis first model is not going to slow down. The questions will get more specific, the answers more nuanced, and the picture more complete. We are living through a genuine scientific revolution in the understanding of how, when, and by whom the Americas were first populated. The textbooks are being rewritten right now, and the story they're converging on is one that should fill anyone who's paying attention with something close to awe. Here's where we've landed. The Clovis first model, 13,000 years ice-free corridor, single migration, is not an accurate account of how humans first came to the Americas. The evidence from Monteverde, Buttermilk Creek, the Galt site, White Sands, and a growing list of other sites puts people here earlier than the traditional model allows, using routes that the traditional model cannot accommodate. The new picture is more complex, more interesting, and in some ways more difficult to reconstruct. It involves earlier arrivals, possibly coastal routes, possibly multiple migration events, populations with diverse genetic backgrounds and distinct technological traditions developing on this continent for thousands of years before the Clovis fluorescence. It involves people tough enough and skilled enough to survive the last ice age in an unknown landscape, resourceful enough to exploit everything from shellfish on the coast to mammoths on the plains, adaptable enough to spread from Alaska to Patagonia across an enormous range of environments. These were not simple people following a simple route. They were extraordinary people navigating an extraordinary challenge. And the fact that we are only now, after a century of archaeology, beginning to understand the depth of what they accomplished is itself a humbling reminder of how much history is still buried in the earth, waiting to be found. The Americas were not discovered 13,000 years ago. They were discovered perhaps twice that long ago, or more, by people who left no written record, who built no cities visible from space, who are known to us only through the stone and bone, an occasional miraculous footprint they left behind. But they were here, and the more we dig, literally and figuratively, the more clearly we can see them. The pre-Clovis story is one of those corners of history where the ground is shifting in real time, where the scientific consensus is actively changing, where new discoveries are rewriting the textbooks, and where the implications extend far beyond academia into questions about identity, ancestry, and who this land has always belonged to. I want to know what you think. Are you surprised by how old the pre-Clovis evidence goes? Do you find the footprint evidence at White Sands as stunning as I do? And what do you make of the mainstream's slow acceptance of these findings? Is that responsible scientific caution or paradigm inertia? to drop your thoughts in the comments, genuinely. This is the kind of topic where the comment section is always more interesting than I expect. If this video changed how you think about American prehistory, or if it confirmed what you already suspected, hit the like button. It helps more people find their way to this kind of deep dive. And subscribe if you want more. We've got a lot of ground to cover. There are still mysteries buried under every continent, and we're just getting started. So I saw 21,000 years ago, a child ran along the muddy shore of a lake in what is now New Mexico. Maybe they were chasing something. Maybe they were playing. Maybe they were keeping up with adults who were moving with purpose towards something we'll never know about. They left their footprints in the mud, and the mud dried and sediment covered it, and thousands of years passed, and the world changed beyond recognition. And civilizations rose and fell, and the descendants of that child's people built their own civilizations on the same land. And eventually, in a blink, geologically speaking, European explorers arrived and thought they'd found something new. And still underneath the sand of a national park in New Mexico, those footprints waited, patient, preserved. Proof of something enormous, that this continent's human story is older and deeper and more extraordinary than we knew. History is not finished being discovered. The ground is still full of secrets, and every secret we unearth makes the human story larger than it was before.